So problem number 6 is asking you to find which of these series are convergent. It gives you 4 options, starting with the first one, tangent of 1 over root n over n. Well, let's see, with tangents and sines, I usually want to use some kind of comparison test. So what I'm going to do is I'm going to compare it to something and see if I can figure out if it converges or diverges. So by using a direct comparison test, I'm going to guess that this is going to converge. And the reason I say that is because I know that with any kind of tangent or sine, I can compare it to what's inside. So if I compare it to 1 over root n times n, that'll be 1 over n to the 3 over 2. That should be convergent. So if I write this here, 1 over root n over n, my comparison in this case will be 1 over root n over n. Now again, I know that taking the tangent of something should reduce its value. So by reducing its value, I know that the right side will always be greater than the left side. Therefore, all I have to do is figure out if this can converge, this will also converge. Well, if I have 1 over n to the 3 over 2 by combining those terms, this is convergent by p series. This is convergent, this should also be convergent as well. So for number 1, I'm going to put a C right there for convergent. Number two is the same kind of deal. We're going to use some kind of comparison test and see what we can figure out. So in this case, what I'm going to say is I'm going to say the same kind of thing. Except in this case, if I compare it to 1 over n squared times n, that'll give me 1 over n. That means that it should be divergent. So I'm going to see if I can prove divergence instead of convergence. So that means that my term is going to be sine 1 over n squared for b sub n. And my a sub n, again, I'm going to compare it to n over n squared. Now there's a problem. Taking the sine of something should reduce its value, so therefore this inequality isn't true. So I need to figure out something else to do. Well, I can still use limit comparison, so if I go ahead and I plug into limit comparison, it says that c is equal to the limit as n approaches infinity of a sub n over b sub n. So if I have n over n squared, that's divided by n sine 1 over n squared. Which means that these n's can cancel, and I'm left with 1 over n squared sine of 1 over n squared, taking the limit as n approaches infinity. Now, there's a rule here that says that if I have sine of something, if I have the same thing on the bottom, or if it's switched, so if it's vice versa, this is equal to 1. And that limit is just says that the limit as n approaches infinity of sine n over n is equal to 1 in that case. So therefore, I can just say that this limit is equal to 1. So c is equal to 1, that means that it's between 0 and infinity, which means it's a finite number. Because of that, if I can figure out if one converges or diverges, the other one will do the same. So if I look back at my series that I compared it to, n over n squared, that in reality is just 1 over n. 1 over n is a divergent series, so therefore this should also be divergent. So number 2 is a divergent series. Number 3, same process as the first two. All I'm going to do is I'm going to compare it to something. I have 1 over n, and I have a 1 over n inside of my sine, so I'm going to try to compare it to 1 over n squared and see if I can get convergence out of it. So, in this case, 0 is less than, so 1 over n sine of 1 over n is less than or equal to 1 over n times 1 over n. So again, sine reduces the value, so if the 1 over n's are the same in front, sine of 1 over n should be less than the other 1 over n. So therefore, this inequality is true. 1 over n times 1 over n is 1 over n squared. 1 over n squared is convergent by p series, so if this is convergent, this should also be convergent. So 3 is convergent. Number 4 could be the same process. However, cosine has a special trick to it, is that if you see a fraction, start out with test for divergence. So what I'm actually going to do is I'm going to take the limit as n approaches infinity of cosine of 1 over n cubed. Taking the limit of this as n approaches infinity, I have cosine 1 over infinity, that's cosine of 0. Cosine of 0 is equal to 1. According to test for divergence, if I get anything other than 0, when I take the limit as n approaches infinity, it should be divergent. 1 is not equal to 0, so therefore number 4 is divergent. So out of these 4 series, I got 2 were convergent, 1 and 3. Which means that my answer has to be A.
The Teaching Center, UF's Learning Resource Center.